Hello there. This is going to be Physics 2, Lab 3. My name is Noah Geiger. Let's get into it. So, introduction here. Our goals. First, we're going to try to measure the distance dependence of the magnetic field due to the small bark magnet. We're also trying to write a glow script code that visualizes the magnet's magnetic field. And we're going to compare the two results and see which one's better. Yeah. And for our results here, we found that our mu to be 4.12 amps meters squared, and then our n to equal -2.5, and we'll go into that more in a second. And fundamental equations, we're going to use two of them. The main one is Biot-Savart's law, basically kind of showing us how to calculate a magnetic field with these two equations here. And then we're going to do the distance dependence formula for a bar magnet. And this equation is going to help us figure out our K constant, which we'll need to calculate our mu. So basically, how the experiment went is you get your phone and you would horizontally push it on this mirror stick until your magnetometer gets a max, and then you would put a piece of tape over it, rotate it 90 degrees, and then do the same thing. And then you're going to put another tape over it, and you'll get that, and you're going to record all your data in your Excel sheet. The system is going to be the bar magnet, and then the surroundings are everything else, basically. Here's some of our data you got here at the different points, and you can see here we able to combine all this data to get our y equals formula. So we have our slope and we have our y-intercept, and this is going to be useful when talking about finding k and mu. And here we go. So distance-dependent equation, we use that, and we can find n because that's going to be our slope, and then we can find k because ln of k equals -14. Solve k. Now finding mu, you just do some algebra, rearrange some equations, and you're going to put the assumption that r equals 1. And in doing that, you can find your mu to equal 4.12 amps per meter squared. So code, gonna go to Python here. Basically, very simple. You're gonna put in your constant right there. You're gonna put in what you found for your mu, and there's gonna be the code here. Uh, and that's gonna calculate your perp, and it's gonna calculate your degree distance. So we have all our data right here. It's gonna give us a nice little visual. Hardest part of this was probably the scaling, figuring out how to code the scaling. So a little bit of detail here. So we're going to compare our results here. So the code had us at this vector of degree off axis, which you get the magnitude of that, and that is going to be 5.04 e to -5. However, our experimental is 1.6 e to -5. So it's about a 67% difference. The discrepancies are probably caused by maybe some electronics were too close, or maybe the magnetometer needed to be recalibrated, or wasn't calibrated enough, or wasn't just measuring slightly off. All things that could result in our experiment being off. The more accurate one, honestly, is probably going to be the experiment, and I say that because uh, the theoretical just does not take in consideration any of the outside things. But theoretical is just a good estimate to tell. I don't think it should be that far off from what it is. So your what if you haven't oriented your experiment to compensate for the magnetic north and have instead laid out your meter stick at some indeterminate angle? Well, we would have to account for that somehow, because that's just kind of how the phone works. So we would probably have to subtract something or add something in order to find it. Our results would just have been off, just because there's a difference between north and then true north and how the magnetic field of Earth. What if you had were to stick two identical magnets together into N and run the experiment again? Very simply, it would have just doubled our results while keeping the same direction, because the that's just how magnetic fields work. You maintain the same direction, but you'll double the result there. And that's all the time I have for today. Thank you so much for watching, and see you next time.